Hi, today I'm showing how to fit, or how I fitted, a simple turbo boost controller, that board on the left, and at the same time how to fit a turbo boost gauge, as you can see here. That gauge there only cost about £10. The container for it was only about £3, eBay, but links in the video description. The board that I'm using as a simple boost controller is actually a dual comparator board you can get for a few pounds on eBay. Just in the process of wiring this into this Freelander TD4. There's a convenient position here to fix the circuit underneath the cup holders. Popped out this, it's got a screw at the bottom, some clips at the side, just pulls out. The power for the circuit I've taken from a couple of wires onto the plug that goes into the digital clock. Again, a couple of screws and a few clips to remove. You can see the clips on here. That just pulls out. There's the circuit. So this was the circuit that I wanted to build. This is my first draft of it. Pause the video here if you need to have a look at it. So, as I say, this was what I was going to build up with that simple comparator board. Unfortunately, on the comparator board, this little potentiometer for changing the reference voltage input to the comparator, the top of that is wired into the internal 12 volts on the board. I was going to prefer if that went off to the power supply to the sensor. Then you've got a better reference, a stable reference to compare your main input voltage to. But since that was wired to its internal 12 volts, and I didn't want the 12 volt supply varying, which of course it will do in the car, depending on your revs and whether you've got headlights on or not, might vary by a volt or so. So instead I've modified this and modified the board also, but on a very simple voltage regulator circuit. Desoldered the little diode that was in series with the power supply connection there, and this is a 7805 chip that I'll put in the video description. Two resistors, 1.5 k ohm each. You can see how long I've been doing electronics because the resistors are really old style, and similarly with the capacitors, a couple of 0.1 microfarad capacitors just to keep the regulator stable. A bit of a lash up, not very pretty, but it does work. And so I'll show you the modified circuit diagram. Here we've got a simple voltage regulator circuit based on just what I happen to have in my spares box. The 7805 is an integrated circuit, which is this little chip here. The markings on the top. 7805 will be amongst those markings somewhere, and it's a 5 volt regulator. But with those two resistors, the value of the resistance doesn't matter too much, give or take what, 50% or something probably at least. You can turn a 5 volt regulator into a 10 volt regulator, and we drive our board then with a nice steady 10 volts that doesn't change with the ignition voltage. The advantage of that then is that you get, it gives it a fixed comparison voltage that you're going to be measuring. You don't want this this reference level you set, which you set to trigger at a certain voltage. You don't want that changing with your power supply. Same for the throttle sensing. So how does this circuit work? Well, first I'm going to have a rotary switch, which I've already put on the top there, as you can see. So this switch, which is going to be a three-way, so these three dotted positions around here are the three ways that the central part switches between those options. It's what's called a two-pole three-way. So there's two separate inputs to it that can be switched to three separate outputs. So the original turbo control solenoid is shown here. On this car, one side of it is connected to 12 volts in the wiring loom, and the other side is normally connected to the ECU. But we're going to cut that wire. When the switch is in position 1, the turbo solenoid is connected back to the ECU like in the standard configuration. This switch is just open circuit, so this resistor is not connected. The reason we have this resistor is that when we switch to, say, position number 2, and let's say we're powering our solenoid independently, so perhaps we're driving it via this relay direct to 0 volts, then the ECU wire may not be connected. That will trigger a warning light on your dash because it sees that as a disconnected turbo solenoid. So this resistor effectively replaces the solenoid and fools it that your solenoid is still connected. So position 2 and 3, that 63 ohm resistor is connected to the solenoid wire. The resistance of the turbo solenoid on this car is about 15 ohms. You'll notice that's quite a lot more. It's low enough to stop it triggering a fault, but high enough so it doesn't put a huge load on the ECU wire in the case where we've got the turbo connected and the resistor connected, which is possible in this circuit. So how does this work? So we have the two other switch settings, 2 and 3. In setting 2, then it uses both of these comparator outputs, these relay outputs. This is a symbol for a relay. NC means a normally closed connection, NO is normally open. And on the symbols on the board, they've used this symboling. So this one, see here at the bottom of my finger, that means normally closed. So this middle one and the outer one are the connections that are normally closed. The middle one and the left hand one is normally open, or NO as I've written here. So this is a symbol for a comparator, this is a symbol for a relay, that's a variable resistor, of which we have 2 on the board. These are the variable resistors here, and they can be adjusted by a little screwdriver. That moves this wiper arm of the resistor high or low, basically setting the voltage input to the comparator. So what we want, for instance, on the map sensor, we want this circuit to be triggered when the input voltage is over 3.8 volts, which is roughly the maximum sort of boost that we want to allow of about 15 psi relative to atmosphere, to 30 total absolute. So we want to set this voltage to around about 3.8 volts. So we twiddle that little potentiometer screw until we roughly get that, or just trigger it until this activates when you see roughly about 15 psi on your boost gauge. So on this relay, when it's not activated, the normally closed connections connect 0 volts through this wire over to either direct to the turbo solenoid if we're in position number 3, so that ignores the effect of what's happening on your potentiometer, which is on the throttle pedal. Or if the switch is in position 2, then the output from this comparator board has to go via the next comparator board, which is over here. This relay and comparator is triggered whenever you've got your foot on the throttle pedal. So anything away from idle, this voltage is going to be higher than this voltage, so you have to set this one quite low so that it does only activate just as you press the throttle pedal. So most of the time when you're driving along, foot's on the throttle pedal, this will be activated, so the normally open contacts will be closed. So this wire that comes from your top channel will then be connected to the middle wire, which then goes back to the turbo solenoid. So, summary, how does that all work? At idle, foot's off the pedal, it cuts the turbo boost, so there's less load on your engine. You put your foot slightly on the throttle pedal, maximum turbo boost, and that applies all the way up until you get a manifold air pressure that exceeds the safety limits of, let's say, 15 psi, at which point it activates this relay and turns off the electrical supply to the turbo solenoid and cuts the boost. Once the boost has been cut, this will then go down again, and it'll then probably oscillate going on and off around the maximum turbo boost level. So that's it, that's roughly how it works. Let's just scan down the circuit diagram. Hopefully it'll work. I haven't tested it yet, but we'll wire it in and then we'll test it. And I'll do you a PDF copy. See the links in the video description if you want it. Otherwise you can just copy it from the screen here. So to install that regulator, which is here, you can see I've actually mounted it where a little diode used to be. So this tiny surface mount diode used to be mounted where that regulator is now. The regulator will do the same job as the diode to protect it from reverse bias. Make sure you wire it up correctly anyhow. Look for the plus and minuses. So these are the symbols for capacitors, two there, 0.1 microfarads, and these are the resistors, 1.5 kilo ohms. And the parts you can get on eBay. I'll put some links in the description. The boost gauge also has a couple of wires that need wiring up direct to the power supply that comes from the ignition switch, the black and the yellow, black being 0 volts and the yellow being the 12 volt supply. Luckily on this car it was fairly straightforward to get wires into the engine bay, and it's just about to feed the boost tube through there as well. And what you can do is get a coat hanger through from the engine bay. You can poke through a grommet that's on the bulkhead, and it comes out roughly this location. Tie a wire on the end of a coat hanger, poke it through, grab the wire, and then you can pull the rest of the wire through. So these are where the wires come out. So this is a drain point for the cavity inside here. To get to the grommet the other side, just have to pull off this cover and do these little clips. Pull off this cover and you see a grommet in there on this car. Relatively straightforward to do. Once you've got one wire through, you can then attach it to other wires and pull the other ones through. These are the turbo control solenoid wires that we need to get to. So you see I've already cut them. It's behind this little clip that just undoes. I think it's a brown and white wire is the control wire to the solenoid. The red and white is 12 volts, so we can just leave connected. That goes into the wiring loom. And then this is the brown and white wire that goes off to the, or did go off to the ECU, does go off to the ECU that we're interrupting. So we just need to connect our wires that are coming through the bulkhead onto these two wires. And one for the MAF sensor. The MAF sensor is located under the manifold. It is this part of the manifold. You need to get this top part off first. You probably need to remove the inlet manifold, which I did previously, and I've got a wire from the output of the MAF sensor already here, ready to connect to our third wire that comes through the bulkhead. And at the same time as we're doing those wirings, we'll connect up our little tap into the air inside the manifold. This is the output from the intercooler, so this is pressurized air. With that boost gauge you get a little three-way connector made of plastic, little air connector. It melted one end with a blowtorch just to close one end off, and drilled a hole through this piece of aluminium. Took it off from these hoses first, of course, so you don't get any rubbish inside the engine. Then hopefully our tube should just connect onto this side piece, which we can then route underneath, round and up into the car to our gauge. And that's it all installed. The wiring ties it up. There's the solenoid connectors, and here is the tubing onto here. I'll just put a cable tie around the end for double security. All these things done up again, so relatively tidy. Worth just mentioning that when I drill this hole, I put a little tap in, a screw thread tap with my tap and die set, just so that you can screw in the plastic so it stays in a bit firmer, a bit more securely, and goes in easier. So that's most of the wiring done. For the wire that goes to the throttle potentiometer, on this car you can get a cable down here, and it drops out the bottom by the pedals, as you can see here, and that has to go up to this potentiometer, which is on the end of the throttle pedal. This is the plug that goes into it, and the best wire to tap into is the red and yellow wire, which is the third one from the top this way round. That has the most range on its voltage output. There's two potentiometers there, that's why there's 6 pins. So tap into that, solder onto it, and tuck the wire neatly out of the way of the pedals. And then the final bit of setup we've got to do is just bridge over these two little solder pads here, connect them with a bit of solder. Now we've got everything wired up, what we've got to do is turn on the ignition And channel 2 is for the throttle potentiometer, so we've got to adjust this potentiometer so that the light and the relay switch just as you start to press the throttle. So that's everything wired up, and I've adjusted these pots potentiometers, which you'll see. So if I just press lightly on the throttle, then you see that little light coming on, and you can hear a click. Let's just do that again. So the light just the end of my finger there. Press release, press release. A little bit hard to see, but trust me, that's right. This potentiometer I've set so that it triggers when the boost gauge gets to about 15 psi, which is the maximum boost that I want to occur. As I say, this is a very simple controller. It's like all or nothing. But in practice, because at low revs, even when the actuator is at maximum and the turbo vanes are turned to maximum, there's very little boost pressure. So there's not a lot of difference between having this switch in switch position 2 and 3. So it's up to you whether you want to include that idle switch control or not. When it hits the maximum at 15, it bounces off in pressure, because again, it's being quite a simple controller. It'll cut the turbo until it detects that the boost pressure has dropped, and then go back up again, so it'll bounce off and on the 15 psi. So we'll see that in a minute. It's going to get a little bit noisy. So at idle, very little boost pressure. You can just about hear it clicking as I'm taking my foot off and on the throttle. It would be better if these relays were replaced with transistors, probably a bit more reliable, but if you just want a simple system, this is it. So let's put it up to 2000 revs, and then we're in position 3 at the moment, and you can see we've got a few pounds of turbo boost, whereas in standard mode, if we switch this back to position 1, which is when it's driven by the ECU, you see the pressure dies away to virtually nothing, and you start to feel it misfiring, and you start to get a little bit of smoke coming out of the back of the car that we can probably see. So that's 2000 RPM. I don't know if you can see there, but there is a little bit of smoke coming out of the back of the car. A little bit hard to see because the weather's quite warm, but if I switch it to position 2 or 3, and then we go back to look for smoke, there's no smoke. That appears to fix the misfiring and the smoking at 2 to 2,500 RPM. See if I can get it to come to the maximum of 15 psi. You'll see what happens when it hits the maximum. Hard to get to that maximum 15 psi when you're just idling, but you saw it a couple of times. When it hits that maximum, it instantly then cuts the turbo boost, drops back down again, and then goes back to boost again. Not a particularly smooth control. You probably could get it better with an electronic control, but for a simple system, that'll do for now. So all we've got to do now is package it away so it doesn't short out against anything. Fortunately, there's a nice little hole spot under here, so I'll drill a little hole in the plastic, cable tie a corner of the circuit board to get in there, insulate up our big 63 ohm resistor. Doesn't need to be this big, but it needs to be a few watts at least, so some reasonable size, and that's it. There's our turbo gauge nicely installed. Be interesting to see what difference it makes to the driving. Unfortunately, I've got to wait till I MOT the car, but hopefully now it'll pass because it stands a better chance of getting through the smoke test. So here it is all installed, and after observing how it actually operates while driving and so on, I decided to disable the throttle control on idle, because there's very little difference between the standard mode, which is what it's in now, and switching it over to effectively having the turbo on full boost all the time, because of course idle, there's very little spinning of the turbo. There's just a fractional difference on how quickly it picks up between standard and more boost. So we rev it up to 3,000 revs, you can see gets up to nearly 5 psi, whereas in standard mode then it gets up to 2 or 3 psi. So a little bit quicker pickup, and it also avoids that annoying clicking which comes from the relays when the throttle is around the idle position. So the only thing that's operating now is one stage of that comparator board, which just cuts it out at maximum turbo boost. When you're typically driving this car in standard mode, you won't get any more than about 15 or 16 psi. After looking up some maximum pressures on the internet, I decided to tweak my maximum limit, so it gets to around about 19 psi. That's as much as I want to risk it. This is not my recommendation of what to do on your car, because of course with more pressure there's always the risk of blowing up the engine, overheating it, blowing a tube going to the intercooler or something. And also I've noticed with that higher pressure an engine warning light will come on. Obviously it's detecting a pressure over boost. Goes away when you switch it back to standard mode, so not too much of a problem. So I just reserved that maximum turbo boost for just occasional usage. I've noticed when typically driving it does pick up a bit quicker, but not a huge amount of difference otherwise, just a little bit more power. So that's my installation. No smoke coming at the back of this now, so it's all good. Thanks for watching. Bye.